Today is our first lesson for covering radical expressions and equations. And we're going to begin by learning how to simplify radical expressions. First of all, defining a radical expression. A radical expression is an expression that contains a square root. And that expression may contain numbers, or it can contain variables, or both. For example, the square root of 5x, this is a radical expression. And the expression under the radical sign, this right here, the 5x, is called a radicand. A radicand is in its simplest form if it contains no perfect squares other than 1. So if I look at this, 5x, and I try to factor it out, I'm not going to get very far because the only factors of 5, since it's a prime number, are 1 and 5. So the only perfect square that contains is 1, and that's allowable. And for x, just 1 and x would be the factors, so same thing. Therefore, this is in simplest form, okay? Compare that with the expression, the square root of 8x squared. This is not in simplest form because if I factor out 8 equals 4 times 2. And since 4 is a perfect square, this expression is not in simplest form. X squared also is a perfect square because it's the product of x times x. So this is also a perfect square. X squared is a perfect square. So this is not in simplest form. Shortly, we'll be discussing how you would change this expression and similar ones into simplest form. Now, a couple definitions and explanations regarding radicals. Recall that there are actually 2 square roots for a number. So if I ask for the square roots of 4, the answer would be 2 and negative 2. And that's because 2 squared equals 4, and negative 2 squared also equals 4. So there are actually 2 square roots for each number, a negative and a positive. However, by convention, when we use the radical sign, we are only referring to the positive square root. So this radical sign means that we're looking only for the principal or positive square root. So when we say we want the principal square root, we mean the positive square root. If I were to be looking for the negative square root of 4, I would express it like this. So then you would take the square root of 4, the positive square root, because that's what the radical is telling you to do. Then you would add the negative to that. And this is the negative square root. So negative square root. So again, when we talk about radical expressions, when you see something like this, it's referring only to the principal square root. Okay, in order to simplify radicals, a very important concept is the product property. And the product property tells us that the square root of a times b is equal to the square root of a times the square root of b. Going back to the example I talked about earlier, the square root of 8x squared. I said that was not in simplest form. So let's take an even simpler radical. Just the square root of 8. I can use this product property to change this into this form and get rid of that perfect square. So first, factor out any perfect squares. So I have 4 times 2. I'm expressing 8 as 4 times 2. Then using the product property, I can split this out into the square root of 4 times the square root of 2. I now have my perfect square separated out from my other factor, and there may be more than one perfect square under here, the products of them, and then the rest of the factors over here. So once I have that done, I can simply take the square root of 4. Again, we're talking about the principal or positive square root, and radical 2. Now, square root of 8 is now in simplest form. Right now, we're going to be writing out each step as you're learning this, but eventually you might just go from this, radical 8, right over to this step. But what's happening in between is actually these steps using the product property. This same property applies to expressions with variables. So a radical expression with a variable such as 24x cubed. Well, if I look at this, what I have is an expression that's containing a perfect square, because I can rewrite 24 as 6 times 4, and I can rewrite x cubed as x squared times x. So now I have all this factored out, but I need to split off the perfect squares. So I'm going to rewrite this using the product property, and I'm going to rearrange slightly. So before I even write this out, split it up according to the product property, I'm going to cluster my perfect squares. So 4 is a perfect square, and x squared is a perfect square. That leaves me with a 6 and an x. Now I use the product property to get 4x squared times 6x. The square root of 4 is 2, and the square root of x squared is x, and that's as far as I can simplify. So I have 2x radical 6x. So again, the product property is very useful in simplifying radicals.